So this is the first side of our Maths Memory Revision card, and let's look at the three key objectives we need to learn during this video. So the first one, we're going to look through on quadratic fractions, factorizing a simple expression. Number two, factorizing a dots expression, and number three, a quadratic, quads we'll call it. So this topic is called quadratic fractions, and as you've guessed it, this week is week 13 over here, and the grading is grade 7. So again, we've left a simple space for you to write your the best questions during this lesson over here, and 3 simple steps we're going to get to at the end of this lesson. Let's turn over for our toolkit. So let's now create our toolkit for quadratic fractions. We just need one section over here, which is section A, a nice big blank space where we're going to create a mind map. So leave this blank, and we're going to fill this in as we go through the lesson. So let's hit on with our first questions on back to basics. Question 1, back to basics. Press pause. I write these 3 parts down, A, B, and C. Press play when you are ready. So this question is all about factorizing, and the key trick with this topic of quadratic fractions is to identify what type of factorizing to use. There are 3 different types, as we'll come across in this topic. So the first thing is this, x squared minus 4, that's part A. What is this going to be? Now this looks like something called dots, difference of 2 squares. Why? Because of this square number over here, the minus 4. Or the 4 should we say. Also we have the minus sign in the middle, that gives it away too, okay, and obviously the x squared term. So when you know it's dots, you just simply write 2 brackets like this. We put x and x over here, and the square root of 4 is simply 2. So plus 2 minus 2. It doesn't matter if it's a minus over here or a plus there, it'll always make sense. So that's simply difference of 2 squares, or as we like to say, dots. Let's just write that down in fact. Okay, difference of 2 squares. Part B. So this one is something called a quad box. And how do we know it's a quad box? Let's look at all these different features over here. So this is the x squared term over here. This is an x term. This is a integer over here. So x squared, x number. That's how we identify this. So when you see this, think of a quad box. We love the word quad box, and we can create this little box over here. It really does help you to do this a bit quicker. So the quad box is over here. So we need to look at the last number over here and think of 2 numbers that multiply to get this 6, okay? And also 2 numbers that add up to get the coefficient of x, which is minus 5. So what 2 numbers multiply to get, let's do dash times dash equals 6. And also that same 2 numbers, dash plus dash, equal a minus 5. Let's think of this, okay, and let's think of the top row first. We'll put the green one just to show the link with this plus 6 over here, and the yellow one accordingly over here, minus 5. Okay, so let's look at the first row first. So multiply to get 6. So 2 and 3 comes to mind first of all. Could it be 2 and 3? Now don't write it down until you are satisfied with the second row first. So 2 and 3, well 2 plus 3 will give you positive 5, so it can't be 2 and 3. So think of how could we get 6? It could be 2 positives or 2 negatives that multiply to get 6. So minus 2 times minus 3 could be here, and obviously minus 2 and minus 3 adds up to get minus 5. We like that. So straight away, let's put our brackets. It's very similar to dots, in fact, x and x. And let's write down what we see in this first column over here, the minus 2, done. And the second column over here, minus 3, done. That's your answer using the quad box. So let's look at part C. So part C, 2x squared minus 8. So what could we do over here? So let's try to use dots. Can we do that? No. Quad box? No. So maybe simple factorizing, which basically is the simplest type you can do. Just look what's in 2x squared and minus 8 separately. Okay. So it's going to be 2 over here, and that's the highest common factor. We can't take anything else out. So x squared minus 4. This is probably the way I would leave the answer in simple factorizing, but we can see this x squared minus 4 looks very similar to part A, so surely we could write it like this, a square bracket and a curly bracket over here. Let's write the dots answer, just as we did for part A over here, and that's would be how you would do your final bit for part C. So it's a bit of simple factorizing and a bit of dots mixed into one. Question 1 continued, parts D, E and F, back to basics. Press pause, write these questions down, press play when you are ready. So part D, so here we're identifying something called an advanced dots. And advanced dots, it is because of this coefficient of x squared, which is 4. So the way we deal with advanced dots is we'll look at it without the 4. Let's ignore this 4, and let's deal with x squared minus 25. So x squared minus 25, x and an x, it'll be plus 5 and minus 5 over here. And we simply now do the square root of 4. We'll look at the 4 now. And this is simply 2, so 2 and 2. So there you have it. You can multiply this out the 4 steps if you want to, but this is advanced dots, and it's quite a simple way of doing it. Okay, so always do basic dots first, and then look at the coefficient of x squared. Part E, so this one is going to be advanced quad box, and we know again it's advanced quad box. Similar reason with the first one already. It's coefficient of x squared, which is 3. Okay, so what we want to do is create the quad box over here, good old quad box. So let's do this over here, and what we want to do really now is to find two numbers that multiply to get a times c. Now what we mean by a times c is actually this number a times c. So 3 times minus 4, so two numbers, dash times dash, multiplies to get minus 12. Okay, I'll put over here 3 times minus 4, that's how we got that, and add up to get the same dash plus dash, add up to get the coefficient of x, which is minus 4. Okay, now how do we do this? So let's think of the first row, and we'll go straight to this. In fact, minus 6 and 2, minus 6 and 2. So we'll write the whole equation out, and what we'll do is sum of these numbers, and we'll sum them in for the x terms. So 3x squared minus 6x plus 2x, we're adding an x to each of these obviously, minus 4. Okay, so this minus 6x plus 2x is the same thing as this minus 4x over here. Notice how we put the minus 6 first, because we're going to factorize in a second. So we call this the Jackie Chan move because we cut this in half. Okay, let's cut this in half. Let's factorize this. So factorize it. What goes into 3x squared and 6x? 3x does, and x minus 2 will be over here. Let's work backwards with this and write x minus 2, because you'll always have the same bracket. And now let's work backwards over here. What could this be? It's obviously going to be plus 2 over here. So let's look at our coefficients in front of our x minus 2 brackets. We have 3x and we have 2 over here. Let's create one bracket from that, and obviously this will leave us the other bracket, which is x minus 2. So final answer would be 3x over here, 3x plus 2, because those are the numbers in front of the x minus 2 brackets, and x minus 2 obviously because that's what's left over. These are always the same brackets anyway. It doesn't make a difference which one we use in there. So that's our final answer, advanced quad box. Let's get to the third one over here. So how do we identify this? What could this be? Now this is an example of something called hidden dots. Why? Because dots is hidden within this. It's quite simple, really, quite self-explanatory. So let's factorize this. We had an example of this, I think, in part C before. So x goes into both x cubed and 36x. Nothing else does. Now what goes into here? Oh, x squared minus 36 does. Now this obviously looks like dots over here, so we're going to write x over here. I'll put a square brackets. Doesn't really make a difference, just to make these differentiated. X plus 6 and x minus 6, and that's hidden dots over there. That's how you do that. Okay, so already a mixture of all different things for this back to basic exercise, but still make sure you understand this before we hit the core steps. So here is your toolkit on the 3 different types of expressions you need to identify in order to do this. And obviously we've covered simple factorizing, dots and quadratics. So use these to go ahead now to our core questions. Question 1, core 1. So press pause, write part A and B down, and press play when you're ready. So here we're dealing with different types of factorizing problems, all within a fraction, hence the word quadratic fractions for this topic over here. So let's identify this numerator, x squared plus x minus 6. This is, guess what, it's the quad box, a basic quad box, because there's no obviously coefficient in front of here. Let's look at the bottom one over here, and this bottom one will be dots. Okay, it's basic dots again because there's no coefficient of the x squared over here as well. Okay, so it's quite a simple question actually. So let's deal with this, the top one. So quad box. Let's look at the quad box and let's create a quick quad box over here. And let's look at two numbers that multiply to get -6 and add up to get 1 because of the coefficient over here. So these numbers will be 3 and -2, 3 and -2. So let's plug this into now our numerator and let's see what we get with this. So let's draw our fraction here and let's see this. So we have on top our two brackets and x, plus 3 and -2. So the bottom denominator, this is basic dots. So basic dots is quite simple. Take the square root of 4. So we have our two brackets again, x, and the square root of 4 plus 2 minus 2. Whoops, and minus 2. Now the beauty about this is that things will cancel. So over here, you've guessed it, it's actually the x minus 2 that cancel. So let's slash these two out and rewrite this as x plus 3 and over x plus 2. That's your final answer with all these steps. Part B. So we won't go into too much depth. Let's look at this first one over here. This is obviously the quad box once again. So the quad box says two numbers to multiply to get 6 and add up to get -5. So let's think of these two numbers, and these two numbers would be, well, multiplies to get 6, adds up to get -5. Okay, let's pick -2, -3. Okay, these come up quite a lot in the exam, two minuses, by the way. So just be aware of that. So we've got on the numerator, we've got these two brackets over here. We've got x minus 2 and x minus 3. So let's write that. So x minus 2, x minus 3. And the bottom one, we have simple dots. We have the -9. Square root of 9 is 3. So x plus 3, x minus 3. These are very, very simple, in fact. We cross out the ones necessary. So the ones necessary are the x minus 3 brackets, because they appear both in the numerator and denominator. Let's cross them out. And let's rewrite this question as, or the answer rather, as x minus 2 over x plus 3. That's your final answer for these two. Let's just highlight these so you know which ones are which. So final answer for part 1 was that, and the final answer for the second part was that. Question 2, core 2. Press pause, write this fraction down, press play when you're ready. So in this case, we're dealing with an advanced quad box over here, advanced quadratic and advanced dots in the denominator. So let's go ahead with this and let's do the quad box for the top bit. So we have two numbers that multiply to get -12 and add up to get -4. So quickly, let's do this over here. Let's create our box and let's see this. So we won't explain too much. We'll go more towards the result on this one. So -12, add up to get, let's say, -4. So we have 3x squared. We have, this would be -6 and 2, by the way, -6 and 2. 3x squared minus 6x plus 2x and -4. Okay, let's do the Jackie Chan move. Okay, let's factorize this. 3x over here, x minus 2, and let's put x minus 2 again, and let's put plus 2. So we end up with basically 3x plus 2 and x minus 2. Let's look at the bottom number over here. So let's look at this. We have 9x squared now. 9x squared minus 4. So this is advanced dots. So let's ignore this 9 over here. We ignore this 9 for 1 minute. Let's just factorize x squared minus 4 like normal. X plus 2, x minus 2. Let's put the 3 back in the game, because 3 now is the square root of 9. This 9 over here. Okay, that's how we got the 3 over here. So that's the fun bit. Two things should cancel. We have the brackets, the similar ones of 3x plus 2 over here. So let's cancel these two out. Put a line / on top of each one like this. There we go. And then we can rewrite whatever is left over here. And the leftover bits are going to be obviously x minus 2 and 3x minus 2. So that would be a final answer for this. So just an example of how we use advanced dots and advanced quadratics in a simple fraction. Question 3, core 3. Press pause, write this fraction down and press play when you are ready. So remember, the key trick is to identify what type of factorizing problem we have over here. So if you look at this numerator 5x plus 10, this is an example of simple factorizing, okay? Let's look at another expression, x cubed minus 4x. This is a basic dot. 3x minus 1, can't do much with that. That's not really anything we can actually factorize, but 6x squared minus 14x plus 4, this is an example of advanced quadratics, advanced quad box. And take note of the divide sign, because we could flip a few things in this question. So let's deal with each one. So the trick is to just identify it and factorize each one of these expressions individually. 5x plus 10, let's factorize this. So 5 outside, x plus 2. Now, this is hidden dots over here. We'll take x outside because x is in both. Treat it like simple factorizing. What goes over here? X squared minus 4. Okay. Take note, we can do something with this x squared minus 4 a bit later on. Divide. Let's flip this around straight away. Okay. So what we see over here goes over here. We'll make this a times sign. Okay. So obviously times, we have 6x squared minus 14x plus 4. And all over, let's say 3x minus 1. Now we've created quite a few brackets over here. That's good, because at the end we're going to cancel these brackets out. Let's deal with this one over here, this advanced quad box, and let's see what we can do with this. So let's do this on this side over here. So two numbers are multiplied to get 6 times 4. Now I'm thinking about this and thinking, let's break this down even further. Let's say if we said to ourselves, we could divide everything by a common factor, which would be 2. We're going to half every single thing. There we go, 2. You should always try to factorize an advanced quad, or anything for that matter. The answer will still be the same, okay? It'll make life much easier for you as well. So let's think of it, this should be in fact 3. Okay, so let's just deal with 3x squared minus 7x plus 2, okay? It'll give us the same answer if we were to take the whole thing in its entirety. So two numbers are multiplied to get 6 and add up to get minus 7. So let's think of two negatives, because obviously the negative over here, so minus 6 and minus 1, minus 6 minus 1, that definitely works. Let's write the whole thing over here. So 3x squared, we'll write minus 6 first, only because we can factorize this in the next step. Minus 1x, or minus x, and this will be plus 2. Let's cut this in half. Okay, 3x over here, x minus 2. X minus 2, I'll write that in terms of writing it first, and we'll put minus 1 over here. So the final answer is going to be 3x minus 1 and x minus 2. So that is your final answer. We could put actually a 2 if you wanted to. In fact, we'll do that because that actually is the full answer, in fact, if you multiply the whole thing by 2 at the end. So the 2 over here is simply going to be the 2 from over here. 2 and 2, okay? It would be wrong if you did not include the 2 in this case, because we're actually factorizing and not solving it. Okay, anyway, enough of that. So let's do the whole thing over here. Now let's write the whole thing again, and let's write this. So 5x plus 2 all over. Now look at this, x, this is dots, basic dots, x plus 2. I'll put a square bracket so you can see each step by step. X minus 2 over here. And this is times 2. I'm going to write what we put over there, 3x minus 1 and x minus 2. And this is all over 3x minus 1. Okay, now the fun bit, let's see what we can cancel out over here. So what brackets look the same? I think we're in a position to do this. So x plus 2, x plus 2. There you go, obviously. X minus 2 and x minus 2 as well. They go on either side of this. 3x minus 1 and 3x minus 1 go as well. So we're left with just this. We're left with basically, what are we left with? 5 times 2, because everything else has been cancelled out on the numerator. And the bottom one, this is just imaginary 1, x times 1, or just x. So 10 over x would be a final answer for all of that. That would be quite a tricky question, but it's quite doable actually, and that involves quite a lot of the techniques we've talked about, simple factorizing, hidden dots, and advanced quad box in this example over here. Question 4 challenge. So press pause, write this question down, press play when you are ready. So this kind of question involves three types of separate fractions, and these come up quite often in the new GCSE. So let's look at the first case scenario, and this is probably what I wouldn't do, but you could obviously use this technique. It's up to you. Okay, it's a bit more complicated, I find, but this is a scenario some students use. So what we could do with this first scenario is to create three separate fractions straight away. So in one go, in one shot, we'll create three separate denominators. Now, we won't do the whole method of this, but in a nutshell, let's think of the three fractions like this. And obviously, let's get our signs in the middle. So we have, let's have the minus sign over here and the minus sign over here as well. Okay, so you'd have your denominator as, if you imagine this as a 1, obviously under here, your common denominator would be x plus 2 and x minus 2 as well. And we would continue that for every single one of these. So you deal with this in the same way you deal with two fractions, but yet we're adding three fractions in one go. And then obviously these numerators on top would be different, okay? But I've just left them blank for this case over here. So let's see now how we would deal with this in case 2. This is what we favor over here. So case 2, let's go ahead with this. So we're going to deal with these fractions separately over here. So first of all, we can look at the first set of fractions, okay? We always look at this first set over here, okay? Never the latter two, the first set always, okay? I'm going to deal with that and get one fraction. And with the answer with that, we're going to now, in the second step, deal with the whole thing over here once we get that first fraction. So in a nutshell, let's deal with the yellow square first. Once we get an answer for that, we're going to now use that answer with this latter one over here. So let's deal with the yellow one first. So we have this x 3 over 1 minus x plus 1 over x plus 2. So let's deal with this. 3 over 1 minus x plus 1 over x plus 2. Let's put a bracket around here as well to make it a bit more nicer. So how do we deal with this? Very, very simple. So we're going to have a answer of x plus 2 as a common denominator. And over here, we're going to have 3x plus 2. And over here, minus x plus 1. Okay, and notice how we put brackets around this. So if we were to just expand that slightly more, we're going to get 3x plus 6 minus x minus 1. And the whole thing is over the same denominator, which is obviously x plus 2. So we're going to write x plus 2 over here. So this leaves us, if we simplify a few things, 2x plus 5. And again, the whole thing is over x plus 2. So that's quite easy. That's actually the yellow bit, the first bit of this, which shows us the answer is 2x plus 5 over x plus 2. Let's deal with the green scenario over here now, and let's look at the whole entire fraction. So we've got our answer from the yellow bit, 2x plus 5 over x plus 2. And let's deal with this green one over here now, minus x minus 5, we'll put that in brackets, over x minus 2. So this will lead us to believe that our common denominator now is going to be x plus 2 and x minus 2 over here. And we're going to have a line over here. And we're going to have x plus 5 over here. X minus 2 minus x minus 5, x plus 2. Okay, so that's going to give us an answer now of, if we multiply the whole thing out, 2x squared minus 4x plus 5x minus 10 all over, this is going to be the same thing over here, x plus 2, x minus 2. We haven't got space here, so I'm going to write over here minus open brackets x squared minus plus 2x rather, plus 2x minus 5x minus 10, all over again x plus 2, x minus 2. Right, let's see, we have more space over here. So now if we expand this, simplify these two middle bits rather over here and take the minus signs, we're going to get this 2x squared plus x minus 10 minus, open brackets, x squared minus 3x minus 10 over x plus 2, x minus 2, which is actually x squared plus x minus 10 minus x squared plus 3x plus 10, which will give us over here x squared, cancel these two things out, plus 4x, if we cancel these two over here, and the minus 10 plus 10 cancel. So we've got x squared plus 4x, and the whole thing is all over our answer of x plus 2, x minus 2. So that could be simplified in our final answer over here in terms of we factorize the top numerator x plus 4 over x plus 2, x minus 2. So that should give us our final answer over here for what we're looking for. So this has now brought us at the end of our maths memory lesson on quadratic fractions. You should learn these three simple key objectives. So the first thing you should learn is how to factorize a basic or simple expression over here. Number two, you should have identified and learned how to factorize a basic or advanced quadratic expression. And number three, how to obviously factorize a basic and advanced quadratic. These are the three different types of expressions you have to factorize and cancel out at the end. So basically these are the three steps: identifying what we've just talked about, the expressions, factorizing them separately, and then cancelling them out each with a bracket. So look through these three steps. Let's turn over to consolidate our toolkit, and let's now hit our let's do it questions. So here is your toolkit on the three different types of expressions you need to identify in order to do this. And obviously we've covered simple factorizing, dots and quadratics. So use these to go ahead now to our core questions. Question 1, let's do it. So press pause, write this question down, press play when you are ready. Question 2, let's do it. Press pause, write this quadratic fraction down, press play when you are ready. Question 3, let's do it. Press pause, write this quadratic fraction down, press play when you are ready. So well done, you have now finished quadratic fractions and should have understood a few key areas of factorizing, things like simple factorizing, basic advanced dots, basic advanced quadratics, how they use them in exams with fractions especially. So make sure you go through the 3 steps, all these questions in this video, go to your revision planner right now and rate yourself with your feel good factor out of 10. So well done.